Hello everyone, welcome to the part 2 of Trigonometry series for class 10 of ICSE students. In this series, we are doing all the chapters of trigonometry from the textbook Concise Mathematics by Selina publication. Today we are going to begin with the question number 11 and we will do the questions till question number 30 of exercise 21A. In case you want to refer to the answers of question number 1 to 10, the link is getting displayed on the screen right now for all of you. Now let's begin with the question number 11. We will start the question from the left hand side, which is equal to 1 plus tan square A divided by cosec square A into cot A. Now we know that 1 plus tan square A is equal to sec square A. So the reasoning is always written in trigonometric questions. So 1 plus tan square A is equal to sec square A according to the trigonometric identity. Now we will convert all the terms here in the form of sine and cos. So sec square A can be written as 1 upon cos square A. Cot A can be written as cos A upon sine A. And cosec square A can be written as 1 upon sine square A. So here this cos and this cos will get cancelled out. So we are left with now 1 upon cos A upon sine A, and this will get reciprocaled. So this becomes sine square A. Now sine A and sine A will get cancelled out. So sine A upon cos A is equal to tan A, and which is the right hand side. So this we have proved. Let's begin with the question number 12 now. The left hand side here is given as tan square A minus sine square A. So we will convert tan square A in the form of sine and cos now. So tan A is equal to sine A by cos A. So we will use that relationship over here. Now we will take the LCM here. The LCM is cos square A. And the numerator here will get cross multiplied. So this will be sine square A into cos square A. Now we will take sine square A as common. So we are left with 1 minus cos square A in the numerator. Now we know that sine A divided by cos A is equal to tan A. So this will become tan square A. And we know that 1 minus cos square A is equal to sine square A by the trigonometric identity. So we will replace the bracket here with sine square A. Now this is the right hand side, what we wanted to prove. So this is proved. Let's now begin with question number 13, and we will start from the left hand side. Left hand side is given as cot square A minus cos square A. Cot can be written in the form of cos and sine as cos square A divided by sine square A, and cos square A will be written as it is. So the reasoning here is cot A is equal to cos A upon sine A. Now we will take the LCM again. So the LCM is sine square A, and sine square A will get multiplied here with the cos square A term. So this will give us cos square A into sine square A. Now from both the numerator terms, we will get cos square A as common. And the denominator is sine square A. Now we know that cos A upon sin A is equal to cot A. So this will become cot square A, and 1 minus sin square A is cos square A. So this is the right hand side, what we wanted to prove. So this is proved now. So let's now begin with question number 14. The left hand side is equal to cosec A plus sin A into cosec A minus sin A. So this is of the form A plus B into A minus B. So we will use the property now. So this will give us the answer as cosec square A minus sin square A by the formula A plus B into A minus B is equal to A square minus B square. Now we can write cosec square A in the terms of cot square A as 1 plus cot square A by the trigonometric identity, and sin square A can be written in the form of cos square A as 1 minus cos square A. The reasoning is cosec square A is equal to 1 plus cot square A by the trigonometric identity, and sin square A is equal to 1 minus cos square A. Now we will open the brackets here. This will become 1 plus cot square A minus 1 plus cos square A. Minus 1 plus 1 will get cancelled out, and we are left with cot square A plus cos square A, which is equal to the right hand side. So hence proved. In the 15th question, the left hand side is given as sec A minus cos A into sec A plus cos A. So we will begin with the left hand side. Again, you can see this is of the form A minus B into A plus B. So we are going to use the formula. So this will give us sec square A minus cos square A, and the formula we have used is A plus B into A minus B is equal to A square minus B square. Now we can write sec square A in the form of tan square A as 1 plus tan square A, and cos square A can be written in the form of sin square A as 1 minus sin square A. So the identities that we have used is 1 plus tan square A is equal to sec square A, and 1 minus sin square A is equal to cos square A. Now we will open the brackets here. So this will give us 1 plus tan square A minus 1 plus sin square A minus 1, and 1 will get cancelled out. So we are left with tan square A plus sin square A, and which is equal to the right hand side. Hence proved. Let's now begin with the question number 16. The left hand side is given as cos A plus sin A whole square plus cos A minus sin A whole square. So we will expand it using the formula A plus B whole square. So this will become cos square A plus sin square A plus 2 cos A into sin A. Now we will expand the second bracket. This will become cos square A plus sin square A minus 2 cos A sin A. The formulae that we have used are A plus B whole square is equal to A square plus B square plus 2AB, and A minus B whole square is equal to A square plus B square minus 2AB. Now 2 cos A minus 2 cos sin A sorry, 2 cos A sin A and minus 2 cos A sin A will get cancelled out. So we are left with 2 cos square A plus 2 sin square A. Now we will take 2 common here. So this will become 2 into cos square A plus sin square A. Now we know by the trigonometric identity that cos square A plus sin square A is equal to 1. We will substitute the value here. So this will become 2 into 1, which is equal to 2. This is the right hand side, hence proved. Let's now begin with the question number 17. The left hand side is given as cosec A minus sin A into sec A minus cos A into tan A plus cot A. Here we are going to convert all the terms in the form of sin and cos. So we know that cosec A is equal to 1 upon sin A. Then in the second bracket, sec A can be written as 1 upon cos A minus cos A, and the last one, tan A is equal to sin A upon cos A plus cos A upon sin A. So the reasoning is cosec A is equal to 1 upon sin A, sec A is equal to 1 upon cos A, tan A is equal to sin A upon cos A, and cot A is equal to cos A upon sin A. Now we will take the LCM here. So this will become 1 minus sin square A upon sin A. The second bracket will become 1 minus cos square A upon cos A. And the last one will become sin square A plus cos square A upon sin A into cos A. Now we know that 1 minus sin square A is equal to cos square A. 1 minus cos square A is equal to sin square A. And sin square A plus cos square A is equal to 1. The trigonometric identity that we have used in different forms over here is sin square A plus cos square A is equal to 1. Now cos A will get cancelled out. The second cos A will cancel out the cos A completely. Sin A will cancel out this completely. So this will give us the answer as 1, which is equal to the right hand side, hence proved. Let's begin with the question number 18. The left hand side is given as 1 upon sec A plus tan A. Now in this we are going to multiply the numerator and denominator by sec A minus tan A. So here the numerator and denominator both can be multiplied with the same expression. The numerator will become sec A minus tan A, and the denominator will become sec square A minus tan square A. The formula that we have used over here is A plus B into A minus B is equal to A square minus B square. Now the numerator will remain as it is, and the denominator is sec square minus tan square A, which is equal to 1, because 1 plus tan square A is equal to sec square A according to the trigonometric identity. So we can rearrange it, and the value that we will get here in the denominator will be equal to 1. Now this will give us the answer as sec A minus tan A, which is equal to the right hand side of the expression, and hence we have proved that the left hand side is equal to the right hand side. This is question number 19, where the left hand side is given as cosec A plus cot A. So we can start with the left hand side as cosec A plus cot A. In this case, we want cosec A minus cot A in the denominator in the right hand side. So we will multiply both the numerator and denominator by cosec A minus cot A. Now the numerator will become cosec square A minus cot square A. According to the formula, a plus b into a minus b is equal to a square minus b square, and the denominator will become cosec A minus cot A. Now the numerator will become equal to 1 because of a trigonometric identity, which is 1 plus cot square A is equal to cosec square A. So we can rearrange it according to this. Cosec square A minus cot square A is equal to 1. So we have put the value here. Now this you can see is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. This is question number 20, where the left hand side is equal to sec A minus tan A upon sec A plus tan A. In this question, we will multiply the numerator and denominator both by sec A minus tan A. If you will closely observe, this looks like a formula of sec A minus tan A whole square. So we will use this formula now, and we will try to create this formula by multiplying the numerator and denominator both by sec A minus tan A. So you know that this is A plus B into A minus B. So this will give us the answer as sec square minus tan square form, and the numerator will become sec A minus tan A whole square. So now we will expand it using the formula A minus B whole square. So this will become sec square A plus tan square A minus 2 into sec A into tan A, and the denominator here will become equal to 1 because of the trigonometric identity that sec square A is equal to 1 plus tan square A. That means sec square A minus tan square A is equal to 1. So we are substituting the value over here. Now we know that sec square A can be written in the form of tan square A as 1 plus tan square A. We are using the same formula here again. In place of sec square A, we will put the value 1 plus tan square A, and the remaining will be added over here. So plus tan square A minus 2 sec A into tan A. So this will become 1 plus 2 tan square A minus 2 sec A into tan A. If you will rearrange the terms over here, you will get it as 1 minus 2 sec A into tan A plus 2 tan square A, which is equal to the right hand side. So hence we have proved that the left hand side is equal to the right hand side. Let's now begin with the question number 21. The left hand side here is given as sin A plus cosec A whole square plus cos A plus sec A whole square Now we will use the formula a plus b whole square and expand it. So this will become sine square a plus cosec square a plus 2 into sine a into cosec a, and similarly we will expand the second bracket. So this will become cos square a plus sec square a plus 2 cos a into sec a. Now we know that sin a and cosec a are reciprocal of each other, and similarly cos a and sec a are reciprocal of each other. So sin a into 1 upon cosec a is equal to 1, and similarly cos a into 1 upon sec a is also equal to 1 because they are reciprocal of each other. So we will get the expression as sin square a plus cosec square a plus 2 plus cos square a plus sec square a plus 2, because this part will get cancelled out. Now this can be written as sin square a plus cos square a plus cosec square a plus sec square a plus 2 plus 2 will become 4. Now we know sin square a plus cos square a is equal to 1 by the trigonometric identity. So we can write it as 1, and cosec square a can be written as 1 plus cot square a. Similarly, sec square a can be written as 1 plus tan square a plus 4. The identities that we have used are sin square a plus cos square a is equal to 1, sec square a is equal to 1 plus tan square a, and cosec square a is equal to 1 plus cot square a. So here we can add the numbers. So this will give us 7 plus cot square a plus tan square a, which is equal to the right hand side. Hence we have proved that the left hand side is equal to the right hand side. Let's now begin with the question number 22. The left hand side is given as sec square a into cosec square a. Now we can write sec square a in terms of tan square a as 1 plus tan square a, and cosec square a can be written in the form of cot square a as 1 plus cot square a by the trigonometric identities. Now both the brackets will get multiplied, so we will get the result as 1 plus tan square a plus cot square a plus tan square a into cot square a. Now we know that tan a and cot a are reciprocal of each other. They will cancel out each other here, and the answer would be 1. So the reasoning here is tan a is equal to 1 upon cot a. So this will get multiplied and give us 1. So we are left here with 1 plus tan square a plus cot square a plus 1, which will become equal to tan square a plus cot square a plus 2, which is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. Let's now begin with the question number 23. The left hand side is given as 1 upon 1 plus cos a plus 1 upon 1 minus cos a. Here we will take the LCM. The LCM will be the product of the two expressions, that is 1 plus cos a multiplied by 1 minus cos a. The numerator will become 1 minus cos a plus 1 plus cos a. Minus cos a plus cos a will get cancelled out. The numerator will become 2 and the denominator is of the form a plus b into a minus b. So the formula that we have used will give us the answer as 1 minus cos square a. By the formula a plus b into a minus b is equal to a square minus b square. Now this can be written as 2 upon sine square a, because we know that according to the trigonometric identity, sine square a plus cos square a is equal to 1, which means 1 minus cos square a is equal to sine square a. Now we know that sine a is the reciprocal of cosec a and cosec a is the reciprocal of sine a. So this can be written as 2 into cosec square a by the relation that 1 upon sine a is equal to cosec a. This is equal to the right hand side and hence we have proved that the left hand side is equal to the right hand side. Let's now begin with the question number 24. The left hand side is equal to 1 upon 1 minus sine a plus 1 upon 1 plus sine a. Here we will take the LCM of the denominators. So the LCM will be the product of the two expressions, that is 1 minus sine a into 1 plus sine a, and the numerator here will get cross multiplied. So this will become 1 plus sine a plus 1 minus sine a. Minus sine a plus sine a will get cancelled out. The numerator will be equal to 2 and the denominator is of the form a minus b into a plus b. So the expression will become 1 minus sine square a by the formula a plus b into a minus b is equal to a square minus b square. Now this can be written as 2 upon cos square a, because we know that by the trigonometric identity sine square a plus cos square a is equal to 1. That means 1 minus sine square a is equal to cos square a. Also cos a is the reciprocal of sec a. So this can be written as 2 sec square a. Since 1 upon cos a is equal to sec a. So this is the right hand side and hence we have proved that the left hand side is equal to the right hand side. Let's now begin with the question number 25. The left hand side is equal to cosec a divided by cosec a minus 1 plus cosec a divided by cosec a plus 1. So here we will take the LCM. Now this is of the form a minus b into a plus b. So if we will apply the formula, we will get the result as cosec square a minus 1 and the numerators will get cross multiplied. So this will become cosec a into cosec a plus 1 plus cosec a into cosec a minus 1. For this we had applied the formula a plus b into a minus b is equal to a square minus b square. Now we will multiply the numerator. So this will give us cosec square a plus cosec a plus cosec square a minus cosec a and divided by cosec square a minus 1. So cosec a and minus cosec a will get cancelled out and the numerator will be equal to 2 cosec square a divided by cosec square a minus 1. Now according to the trigonometric identity, we can put the value of cosec square a minus 1 equal to cot square a. So this will become 2 cosec square a upon cot square a, since cosec square a minus 1 is equal to cot square A. Now we will convert it in the form of cos and sine. So this will become 2 into 1 upon sine square A into cos square A upon sine square A. Sine square A and sine square A will get cancelled out. So for this we had used the relation that cosec A is equal to 1 upon sine A and cot A is equal to cos A upon sine A. So now we are left with 2 divided by cos square A, and 2 divided by cos square A can be written as 2 sec square A, since 1 upon cos A is equal to sec A. Now this is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. Let's now begin with the question number 26. The left hand side is given as sec A divided by sec A plus 1 plus sec A divided by sec A minus 1. Now we will again take the LCM here of the denominators, and the LCM will be the product here. So sec A plus 1 into sec A minus 1 will be the LCM. This will get cross multiplied. So we will get sec square A minus sec A, and this again will get cross multiplied. So we will get sec square A plus sec A in the numerator. Now minus sec A plus sec A will get cancelled out. So we are left with 2 sec square A here. The denominator is of the form A plus B into A minus B. So we will apply the formula and we will get the answer as sec square A minus 1 here, because of the formula A plus B into A minus B is equal to A square minus B square. Now this can be written as 2 sec square A in the numerator, but the denominator can be written as tan square A by the trigonometric property that 1 plus tan square A is equal to sec square A. That means sec square A minus 1 is equal to tan square A. Now we will convert the numerator and denominator in the form of sine and cos. So sec A is the reciprocal of cos A, and tan A is sine A upon cos A. So this will get cancelled out, and the relation that we have used here is sec A is equal to 1 upon cos A, and tan A is equal to sine A upon cos A. So now we are left with 2 divided by sine square A. Now 2 divided by sine square A can be written as 2 cosec square A, since 1 upon sine A is equal to cosec A, and this is equal to the right hand side. So hence we have proved that the left hand side is equal to the right hand side. Let's now begin with the question number 22. The left hand side is given as sec square A into cosec square A. Now we can write sec square A in terms of tan square A as 1 plus tan square A, and cosec square A can be written in the form of cot square A as 1 plus cot square A by the trigonometric identities. Now both the brackets will get multiplied, so we will get the result as 1 plus tan square A plus cot square A plus tan square A into cot square A. Now we know that tan A and cot A are reciprocal of each other. They will cancel out each other here, and the answer would be 1. The reasoning is tan A The next question is question number 27, and the left hand side is given as 1 plus cos A divided by 1 minus cos A. Here we will convert cos A in terms of sec A. So this can be written as 1 plus 1 divided by sec A divided by 1 minus 1 divided by sec A. Since cos A is equal to 1 upon sec A. Now we will take the LCM of this. So this will become sec A plus 1 divided by sec A. We will take the LCM of the denominator here. So that would be sec A, and the numerator here will be sec A minus 1. Now sec A will get cancelled out, and we are left with sec A plus 1 divided by sec A minus 1. Now we will multiply the denominator and numerator with sec A minus 1 because we want a square here in the denominator. So this will be multiplied with sec A minus 1, and the numerator also will be multiplied with the same expression. So this is of the form A plus B into A minus B, which will give us sec square A minus 1 as the answer, and this denominator will become sec A minus 1 whole square. Now we know that sec square A minus 1 is equal to tan square A, and sec A minus 1 will be written as it is. The identity that we have used over here is 1 plus tan square A is equal to sec square A. That means sec square A minus 1 is equal to tan square A, and here you can see this is equal to the right hand side. So hence we have proved that the left hand side is equal to the right hand side. The next question is 28, and the left hand side is given as cot square A divided by cosec A plus 1 whole square. So we know that cot A can be written in the form of cosec A as cosec square A minus 1, since by the trigonometric identity 1 plus cot square A is equal to cosec square A. That means cosec square A minus 1 is equal to cot square A, and the denominator can be written in the same form. Now the numerator can be written as square of both the terms, that is cosec A whole square minus 1 square, and the denominator can be written in the same form. Now this becomes of the form A square minus B square. So this will become cosec A plus 1 into cosec A minus 1, and the denominator will become cosec A plus 1 into cosec A plus 1. This is because A square minus B square is equal to A plus B into A minus B. This is for the numerator. Now we can cancel out cosec A plus 1, cosec A plus 1. Now we know that in the right hand side the terms are consisting of sine form. So we will convert cosec in the form of sine as 1 by sine A. And in the denominator also the cosec A will become 1 by sine A. This is by the relation that cosec A is equal to 1 upon sine A. Now we will take the LCM here. So this will become 1 minus sine A divided by sine A, and in the denominator it will become 1 plus sine A divided by sine A. So sine A and sine A will get cancelled out, and we are left with 1 minus sine A divided by 1 plus sine A, which is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. Let's now begin with the question number 29. The left hand side is given as 1 plus sine A divided by cos A plus cos A divided by 1 plus sine A. So here we will take the LCM. So LCM will be the product of the two expressions, that is cos A into 1 plus sine A The numerator will get multiplied here. So this will become 1 plus sine A whole square, and the denominator and this numerator will get multiplied. So this will become cos square A. Now we will apply the formula of A plus B whole square here. So this will become 1 square plus sine square A plus 2 sine A plus cos square A divided by cos A into 1 plus sine A. Now we know that sine square A plus cos square A is equal to 1. So this will become 1 plus 1 plus 2 sine A divided by cos A into 1 plus sine A. Now 2 can be taken out common from the numerator. So this will become 2 into 1 plus sine A, and the denominator will remain cos A into 1 plus sine A. 1 plus sine A, 1 plus sine A will get cancelled out. So this will become 2 by cos A now. 2 by cos A is equal to 2 sec A, since 1 by cos A is equal to sec A, because cos A and sec A are the reciprocals of each other, and this is equal to the right hand side. Hence we have proved that the left hand side is equal to the right hand side. Let's now begin with the last question of this session, which is question number 30. The left hand side is given as 1 minus sine A divided by 1 plus sine A. In this question we will multiply both the numerator and denominator by 1 minus sine A. Now the numerator will become the square of 1 minus sine A, and the denominator here will become 1 minus sine square A, since A plus B into A minus B is equal to A square minus B square. Now we know that 1 minus sine square A is equal to cos square A by the trigonometric identity. Since sine square A plus cos square A is equal to 1, that means 1 minus sine square A is equal to cos square A. Now 1 minus sine A and cos A both are having the square powers. So we will take the square power outside as common. Now this will become 1 divided by cos A minus sine A upon cos A whole square. So this part becomes sec A minus tan A whole square, since 1 by cos A is equal to sec A, and sine A upon cos A is equal to tan A. Now this part is equal to the right hand side. So hence we have proved that the left hand side is equal to the right hand side. I hope you liked this session, and stay tuned for the next session, in which we are going to complete the question number 31 to question number 48 of exercise 21A. Have an awesome day, and before leaving, please do like and subscribe to this channel. Thank you.